8. Today you will be 4 students join. Okay. When is our final? Monday at 10. Like our class time, right? So 10 to 12. Have you started the practice exam?
Yeah.
Okay. So, hi. You have the weekend to study because our exam is on Monday. So make sure you do the practice exams and then watch the video session recording. And then use red pen to make sure you correct each sentence. Okay, and understand all the steps and the formula needed for the final exam. Okay, everybody?
Then we can use the solution as we go along with using the practice exam.
Huh?
If we forget something on the practice exam, we can use the solution. And like,
Once you look at the solution, use red pen. I would say,
because that's how I do it. Like if I forget something on the practice exam, like I'll look at the solution a little bit. See how we did it.
okay. How about that? Let's look at the problems and then I tell you what section of the notes. Because I don't want you to look at the answer. If you look at the answer, then you lose the opportunity to practice on your own, right? So, okay. So this is the practice exam. Okay. This problem is about domain and it's about domain, right? And you have a problem like this in exam 3. Do you remember?
The first one.
Yeah, yes. So right now, okay, exam 3, problem 1. Then you can look at that problem and then review that problem and try to do this problem on your own. And this one is how to solve quadratic equation, right? So this is like in exam 1. Also this is also in exam 1, right? You have equations of rational expression. So also exam 1. And then this one, exam 3. Okay, everybody? Exam 3. This one, also exam 3. So you have similar problems from exam 3 and also the practice exam 3. Yes? Everybody? Okay. This one, in the practice exam 3. This one, equation passing through 2 points using the self-intercept form. Exam 1. Okay? And then here, write the standard form of the parabola, having vertex and passing through a point. Exam 2. Okay. And here, rational expression. This is a rational root theorem to find a root and then use either long division or simplified division. This is what? Exam 2, right? Rational root theorem. Exam 2. And then this one, in your final, I won't ask degree 4 polynomial. So this won't be on the final. But you have similar problems in your notes, class notes, session 3.4. Okay? And then this one, yeah, you've seen something like this in exam 2. Okay, everybody? Exam 2. And this one, graph the polynomial function, exam 2. Here, write down the, draw the rational function. This is exam 3, right, everybody? You just had this problem on exam 3. And then this one, transformations. Even though I can only give you one picture, but you draw this on here, those are the intermediate steps. Okay, and this is, I think you have seen this in exam 1 and exam 3 as well, right? And yeah, the log one is in exam 3. We have exponential function on log. Okay, now this is what? the chapter 6, right? Solve system of linear equations. So 6.1, 6.2. And yeah, this one, we have system of nonlinear equations, right? What do? You compare both equations and you find which equation has the x or y power 1, right? And with coefficient 1, then you can use the substitution method, right?
In that equation, would you want to set the bottom equation by y or x?
Okay, if you solve for x, then it's just negative 2y.
Okay.
If you solve for y, it's negative x over 2.
Mm-hmm.
Do you like fractions?
No.
No, so solve for x in terms of y.
Right.
So even though no matter what method or which way you do, they will work. But working with fractions is very easy to make mistakes. Do you agree? Yeah, for me, working with fractions is very easy to make mistakes. Let's try to avoid fractions. And then the third problem is what we're talking about now. System of 3 equations and 3 unknowns. Okay, everybody? Mm-hmm. Yeah, so I would say review all your exam 1, 2, 3, and then our new stuff. Then start the practice exams. So don't look at the solution because I want you to know, okay, what you can do on your own and which one is you are not like strong enough. Okay, then you use red pen for that part. Then you know your weakness. Then you can improve. Maybe find more problems to practice. Okay, everybody? Mm-hmm. So, yeah, last time we talked about 6.3, right? And we talked about how to solve system of 3 equations and 3 unknown. And like here, we use elimination method. Let's do. We have 3 equations and 3 unknown. So we want to eliminate one variable. We compare the coefficients of x, y, and z, and we realize the variable x has easier coefficients. Do you agree? It's simpler coefficients. Then we look at the least common multiple of 1, 3, 2, which is 6. Therefore, you want to match 6x. Equation 1 multiplied by 6, equation 2 multiplied by 2, equation 3 multiplied by 3, and you get equation 4, 5, 6. Is that okay, everybody? Mm-hmm. And then you have 3 equations. You use 2 pair of them to eliminate x. So you can use equation 4 and 5, then you get rid of x, and also try your best to simplify. If all the terms have a common factor 4, you want to divide it by 4. Is that okay, everybody? Yeah. And here, equation 5 and 6 eliminate the x. We get 5y plus 13z equals to 29. You see, now we have a system of 2 equations and 2 unknown. Then we also use elimination method. Well, compare the coefficients. Looks like the variable y has simpler coefficients. Right, everybody? So we eliminate the variable y. The LCM, least common multiple of 1 and 5 is 5. So that's why equation 7 multiplied by 5, and then this is equation 8. See? The y is the same. So we can subtract them. And then you get 3z equals to 9. You get the z. And then you plug in one of these 2 equations to find the y. And we compare equation 7 is easier, so we plug in equation 7, we get the y equals to 2, and then you plug in z and the y back to one of these equations, and then we compare equation 1 has easier coefficients, so we plug in equation 1, and we get x is 5. Do you still remember, everybody? So I remember last time teacher asked me, can we multiply by like negative 2 instead of 2. But if you're negative here, instead of subtracting the equation, you add the equations. Yes. So doesn't matter if it's positive, if it's the same, then you subtract the equation. If one is positive, one is negative, then you add them. Is that okay, everybody? Yes? All right. Now, let's look at example 2.
Also, do you have a quiz?
Oh, yes, sure, I have. Yes. Okay, so, right, let's look at the quiz. Okay, so this is it wrong course? Oh, okay. Okay, is it here? No, here. Okay, here. I post the wrong one. Okay, let me fix it. Okay, 10:30. All right. Okay, this one will work. Okay, wish. Okay. Now I just refresh. Is it the same? 10. Okay, no, I need to refresh again. Is it 10? Okay, 10:30, quiz 7. Okay. All right. This is your quiz. The first problem, this is a nonlinear equation, right? Everybody? We compare the coefficient. Oh, you see, the first one, you have x squared. And then the second one, you have all the x and y there, just power 1, right? So it's easier to take equation 2. And you see the coefficient of x is 3. The coefficient of y is -1. Right? So it's better to solve for y in terms of x. So that's why I add y on both sides and I subtract 9. I get y equals 3x minus 9. And then I plug in the first equation, x squared plus 4 times y. Y is 3x minus 9 equals to -8. Is that okay, everybody? So we distribute, this is 12x, and 4 times 9 is 36, and equals -8. And then when you solve quadratic equation, you want to move all the terms to the left-hand side, so your right-hand side is 0. That's why we add 8 on both sides, and we get this. You either factor it or use the quadratic formula. Is that okay, everybody? So that's why we get 2 roots. And we get 2 roots. How about our y? Oh, our y is 3x minus 9. So when x is -14, my y is 3 times x, -14, and minus 9, which is -51. Is that okay, everybody? And then when x is 2, 3x, x is 2, minus 9 is 6 minus 9, which is -3. Okay, so when you work with these problems, try not to use decimals. Give me fractions, okay? So give me exact answer. You usually only keep the decimals when you have a real world problem, like a story problem. Okay, other than that, usually give me exact answer. Okay, so that's why we have 2 solutions. You can either use this expression, okay, x equals y, y equals y, or you can give me points. They mean the same thing. Okay, everybody? This is the first problem. The second problem, okay, hi, Nikema. The second problem, we want to eliminate x or y. It looks like eliminate y is easier, right? Because the least common multiple of 4 and 2 is 4. So equation 2 times 2, we get 4x minus 4, so 6x minus 4y is 14. And then we want to get rid of the y, so equation 1 plus equation 3, 5x plus 6x is 11x. 14 minus 2 is 12. Therefore, x is 12 over 11. And then we plug in one of the equations. Let's plug in the second equation. So 3x is 12 over 11 minus 2y equals 7. 3 times 12 is 36. And minus 2y equals to 7. Subtract 36 over 11 on both sides. So negative 2y equals 7 minus 36 over 11. So when you subtract fractions, you need to have a common denominator, right? So that's why the 7, you need to multiply by 11 on the numerator and denominator. So you get 77 over 11. Right, everybody? And then 77 minus 36 is 41. So we get 41 over 11. And y is both sides divided by negative 2. So we get negative 41 over 22. All right, so let's look at the mistakes. Where's the mistakes? Oh, here. Okay. So it's good to have a mistake book to collect all the mistakes because we learn from the mistakes. Okay, so here it's correct up to here. Okay, but when you divide it by 4, 82 divided by 2 is 41, but then you still have a 2 there, so that's why it's negative 41 over 22. So yeah, this step is correct, but this step we still have the 2 downstairs. Okay, and then here you see you have 2 solutions. This solution gives you 14 and 3 times 14 and 33. Okay, and then the second equation is 2 negative 3. So don't forget that. You have 2 points. And the next one, oh, here. So write down your expressions, your operation. What are you doing here? You are using equation 3 minus equation 4, right? Equation 3 minus equation 4. Do you see 12y minus negative 10y? It becomes plus 10y. So 12y plus 10y is 22y. So that's why it's negative 41 over 22. Okay, everybody? And then here, oh, this side. So we're subtracting, 3 minus 4. 35 minus negative 6. It becomes 35 plus 6 is 41. Okay, everybody? So that's why this is 41 over 22. So this mistake is similar to the last mistake. The last mistake, we forget to change the sign here, but this mistake, we forget to change the sign here. Okay, everybody? Yes. So you see, you're not alone. Sometimes those are common mistakes, and it's okay to make mistakes. For math, if we do something wrong, just get another piece of paper and then you do the problem again. It won't be dangerous. It's not like you're doing an experiment and you cannot go back. So that's why I hope after you finish the problem, check it multiple times before you submit. Okay, and then here, 9 plus y squared is 81 plus 18y plus y squared. So that's why this is y squared. You have a quadratic equation. And then you solve for y. So this is not a linear equation, it's a quadratic equation. You get 2 roots, and then you plug in your x to find the x values. Do you realize this method may be harder than the method in the solution because you involve fractions? Okay, and you see this number 81 and 18 is so big compared to our solution. Our solution, I just get x squared 12x and negative 36. So there are so many different ways to solve a system. Some way are easier, you can finish in 10 minutes. some ways are harder. It might take you half an hour to do it. Okay, so that's why compare the coefficients, compare the equations. Which one, which method, which way is the fastest and easiest, and the numbers are easier to work with. Okay, everybody? Mm-hmm. All right. Oh, right here. Yeah. Okay. And here, so you both sides multiply by 11. And it means you multiply each term by 11. This multiplication, consider it as one term. So you multiply by 11 only one time. Okay, everybody? Each term multiply by 11 one time. So this is one term. You multiply by 11, that cancel the denominator. So don't multiply by the 3 by 11, because if you multiply the 3 by 11, it's like 2 times. You multiply 11 2 times. Okay, everybody? So that's why this is, you cancel the 11, you have 3 times 12 is 36. Okay. Yes. All right. And yes, here it's not okay. It's the requirement. The student know how to do it, but it's the requirement. Please give me exact answers. Okay? Don't round your answers. So usually, if I ask you to round your answer, I would say that it's a problem. Do you remember sometimes I ask you, okay, solve this equations and then round your answer to 3 decimal places. If I want you to round your answer, I would say that. Okay? Or story problem, then you can round your answer to 2 decimal places. But other than that, give me exact answers in fractions. Okay, everybody? Mm-hmm. All right. Okay, so that is the quiz. Any questions about the quiz? All good? All right. Okay, so yeah, let's look at example 2. Oh, by the way, this is our evaluation. We get 67%. So everybody will get 0.2 extra credits. Yes. If we have one more student, I think we can reach 70%. But I think all of you already feel out, right? Mm-hmm. Yes. Okay. All right. So yes. Okay. So which variable do we pick to eliminate? X. Right? Everybody agree? Eliminate x. What's the least common multiple of, what's the coefficient? 3, 1, and 2. What's the least common multiple of 3, 1, 2? 6. Okay, this is equation 1, equation 2, equation 3. Equation 1, what number do we want to multiply? How about Alice's? 2, yes. If you multiply by 2, could you tell me what the equation is? Mm-hmm. Mm-hmm. Thank you. And we call this equation 4. Okay, 你可以吗? The second equation, what do you want to multiply by? Oh, do you need a handout? You have? Oh, yeah, we're here a little Wednesday. Then it's the same handout. Okay. Well, yeah, we multiply by 6. Then what do you get? -18. Yes. This is equation 5. Okay, the third equation. What do you want to multiply by? Peter? Yes. And then what do you get? Yes. So equation 6. Right, everybody? So we have matched all the success. right? Then we pick 2 pair to carry out the x. Ethan, which pair do you pick?
Let's do 5 minus 4. No.
Yeah. 4 minus 5 or 5 minus 4?
Let's do 6 minus 5.
6 minus 5. Okay. Think about it. 6 minus 5 or 5 minus 6. Which one will give you positive coefficient?
5 minus 6.
Yeah. Do you see a negative 80 and minus negative become plus? Okay. So we have 5 minus 6. Yeah. What do you get, Ethan?
You get a lot of numbers. You get a hold on.
Negative 80 minus negative become plus 27.
Yes. 9.
9. Why?
Yeah.
And how many z?
Well, minus 12.
Minus 12. Okay. Equation 5 minus negative.
Oh, then it's 36.
Yes, 36. So 36 equals what?
Negative 63. No, 63.
Yes, 63. Okay. So when you subtract equations, remember minus negative is positive. Okay, everybody? Yes? All right. Good. This is, we call it equation 7. Okay, give me another pair. Caleb.
4 minus 5.
4 minus 5. Okay. Then what do you get?
2y plus 18 equals 14.
Thank you. Okay. Oh, by the way, I forgot to simplify it. Do you see here? All the terms have a common factor 9. Yes. So we can simplify it. Colin, if you divide it by 9, what do you get?
1 plus 40 equals 7.
Yes. Okay, let's call this equation 7. How about this equation? Do you see all the terms have a common factor 2? If you divide it by 2, what happens? Colin.
The same thing.
Yeah. We get the same thing. Right, everybody? We get the same thing. What does that mean? Well, if you use equation 7 minus equation 8, you just get 0 equals 0. Infinitesimal solution. See? It's the same thing. It means it's the same line. So we get infinitely many solutions. Okay. So, do you remember when we have a system of 2 equations, 2 linear equations and 2 unknown? Then it's like 2 lines on the xy plane. We can have 1 solution, no solution, or infinite many solutions. For 3 linear equations and 3 unknown, the number of solutions, we also have 3 possibilities. It can be 1 solution, or no solution, or infinitely many solutions. So example 1, we have 1 solution, right? Example 2, we have infinitely many solutions. Okay? I didn't put example 3 here, but I can tell you, for no solution, you get something like, okay, let's say if you have 10 instead of 7. Then when you do the subtraction, you get 0 equals 3, which is impossible. Then you say no solution. Okay, everybody? So we have 3 possibilities. All right. Okay. But on the final exams, the problem you get, hopefully you only get one solution. Okay? You will have one solution case. Alright.
Stop there and don't solve for x.
No, there's nothing we can solve. It's infinite many solutions.
Can't like plug in 0 or.
No, because every answer is.
No. Okay. What does this mean? This means we have a one parameter family. Okay. So in our course, you can just say infinite many solution. Then you can stop. But if you want to like go to higher math course, they want you to express your solution as a one parameter family or two parameter family. Then what do? You say, okay, so this is outside of the course. You would do let, because infinite many solution, then it means there's at least one parameter. So let's say we let z, the last variable be t. Okay, everybody? And then from equation 7, you get y plus 4z. Z is t equal to 7. What is y? Yes. Good. And then you plug in one of the equations to find x. Which one do you plug in? Which one is easier? The second one, right? And so plug in the second one. We have x minus 3y plus 2z equals to 5. We move the y and z to the other side. Do you know that when you move, the sign changes? So minus 3y becomes plus 3y, and the 2z becomes minus 2z e plus 5, right? And the y is what? Negative 4t plus 7. And the z is what? T and plus 5. When you distribute, Cora, what is 3 times negative 4? And 3 times 7? 21 minus 2t plus 5. Okay, how many t? Yeah. And what's the constant? 26. See, you have your x's negative 14t plus 26. Your y is negative 4t plus 7. Your z is t. And t is any real numbers. So this is a one parameter family. And one parameter family, what does that mean? It corresponds to a line in space. Okay? A line in the space. Yes, it's a line in the space. Do you know how to draw a point in the space? You know how to do that? Okay, let me teach you. So draw a point in a space. Let's say you have 1, negative 2, and 3. How do you plug this point in space? You have the x-axis, y-axis, and z-axis. And then the origin is in the middle. Is that okay, everybody? Your x is 1. So start at the origin, go to the x-axis direction, 1 unit. Okay, everybody? 1 unit is here. And then, y is negative 2. Negative 2 means we go to the opposite y direction for 2 units. Yes, everybody? So that's why we go back, okay, 1, 2. So we go back the negative y-axis for 2 units. And then do you see the z coordinate is 3, which means we go up 3 units. Okay, everybody? So go up 3 units. 1, 2, 3. So this is the point 1, negative 2, and 3. Okay, everybody? So how many points can fix a line? 2 points. Okay? So how do you draw this point? Okay, you can plug in t is 0, right? You get 1 point. And then you plug in t is 1, you get another point, and then you just connect those 2 points. Is that okay, everybody? Mm-hmm. All right. So, yeah. For example, when you plug in t is 0, do you get 2670? Right, everybody? 2670. So if you want to draw it, 26, let's say this is 26. 7, let's say this is 7, and 0. So, which is right here. So this is on the xy plane. And then you plug in, how about t equals to 1? Okay, when t equals to 1, what do you get? Nikema, what do you get? Mm-hmm. Then negative 14 plus 26 is 26 minus 14. 12, right? Everybody? We plug in t equals to 1. So 14 times 1 is 14. So 26 minus 14 is 12. How about the next entry? 3, right? And then the last one? 1. Okay. How do you plug this? Okay, so you go here 12, and then you go here 3, like here. Then you go up 1 unit, so like here. So you connect those 2 points. This is the line in the space. You have 1 parameter that way. 1 dimension. See, a line is 1 dimension. So that's why you have 1 parameter. If the t is a free variable, you get a line. Okay? Sometimes you might have 2 parameter family that is 2 dimensions. You get a point instead of a line. Okay, everybody? Mm-hmm. So, yes, more about the vector stuff in a higher math class like Calculus 3 and linear algebra. Okay? All right. Yes, so this is what happens if you want to go further for infinite solution. And then for no solution, it's just no solution. Then you don't need to do anything to it. Okay, everybody? So next page. Graphically, we have also the 3 possibilities. No solution. Okay, can we draw a picture of no solution? All right, so it could be, do you know that a linear equation in 3 variable is a plane in R2, R3. Have you seen R3? The symbol? Yes. So it's a XYZ space. Okay. R3. So a linear equation in 3 variable is a plane in R3. No solution. It means those 3 planes does not intersect. So one possibility is those 3 planes, all of them are parallel. Right? Everybody? Then they don't intersect. And it could be, okay, the next picture, this one is harder to draw. Okay, let me try to draw it. You'll have one plane like this, and then another plane like that. And then the third plane, like that. Ooh. Can you imagine? You have 3 planes. So this plane, these 2 planes intersect at this line. This two plane intersect this line, and this two plane intersect this line. But they don't have common intersections. The two of them intersect each other, but not three of them. Okay, so no solution. How about one solution? Okay, one solution. You have a plane like this. The second plane like that, and the third plane. Okay. Can you imagine? One plane like this, another plane like that, and then another plane like that. Do you see the intersection is a single point? So that's why it's one solution. That single point is the one solution. It took me a while to practice how to draw this picture. A lot of lines. Okay. Infinitely many solutions. Well, it could be three planes intersect a one parameter family, so they intersect at one line. Okay, or like that. Can you imagine the three planes intersect one line? Oh, it's like a book. Do you agree? It looks like a book. It has so many pages, but it intersects at one line. So in this case, this is one parameter family. The intersection is a line. Or all three planes are the same plane. Well, then you get a two parameter family. So there's still infinitely many solutions, but here intersect at one line, and here all three planes are the same plane. So that's why you get a line. And you see here, the dimension is 2. It is a plane. Here, the dimension is 1. Okay, so those are all the possibilities. And then for higher dimension, R4, R5, they're not able to do it. So use your imagination. Okay. And so that is for all your Yes, that is our course Apply Algebra, or sometimes other school call college algebra. Okay. How many of you need to take trig? Okay. Have you registered? Okay. Okay. Yes. Trig. Okay. Good. So right now, I would like to maybe have a little review. Okay. So do you see down here it says final review notes? I write everything on those 2 pages. So it has everything we learned in this course. Okay, everybody? So I'm not sure, we only have 5 minutes. I'm not sure whether we're able to talk about all of those, but I hope you can look through it, okay, at home. And then review all your past exams, do the practice exams, and then watch the review session for it. Okay, let's try our best and see how much we can cover. By the way, do you know today we have engineering cookouts? At 11, they will have food outside in the Snyder. Okay, how do we find x-intercept? X-intercept is the graph plots the x-axis, so the y is 0, and you solve for x. Right, everybody? How to find the y-intercept? Y-intercept, you cross the y-axis, so your x is 0. So you plug in x is 0 and solve for y. Okay, everybody? And your answer should be at points. X coordinate and y coordinate. X equals to a number is a vertical line. Y equals a number is a horizontal line. So don't give me an equation, it's a line. Give me a point for x-intercept and y-intercept. Okay, everybody? Circle formula, equation of circle. So, by the way, all the useful formulas for exam 1, 2, 3, you still have those. Make sure you can memorize all of them. Okay, because we need them for the final. Okay, so the center is H and K with the radius is R. And you also need the midpoint. I think it's missing the midpoint. What is the midpoint? You get what? You get 2 point x1, y1, and x2, y2. Midpoint is the average of them, right? Average x1 plus x2 over 2. Is that how you calculate average? And then y1 plus y2 over 2. This is the midpoint. Also, what's the distance formula? You have, remember you have, let's say you have 2 points. This is the distance. And then this is the change of x. This is the change of y. By Pythagorean theorem, the distance squared is change of x squared plus change of y squared. That's why the distance is square root of change of x. So x2 minus x1 squared plus change of y, y2 minus y1 squared. Okay, so have the picture in your mind, and then you understand it, then you can write down the formula. Okay?
Why is it the square root?
Oh, because it's Pythagorean theorem. And you want to solve for d, that's why you take the square root both sides. You get d. It's the square root of that. Yes, right. Okay, slope intercept form. So is the coefficient of x. Y is the, b is the y-intercept. Actually, the y-intercept is 0, comma b. It's not just b. Okay? And depending on your slope, you have positive slope, negative slope, slope is 0, or slope is undefined. Right, everybody? 2 lines, if they're parallel, what happens to their slope? The same. 2 lines perpendicular. Negative reciprocal. Yes, very good. Point slope form. Y minus y1 equals m times x minus x1. Yes, everybody? And m is the slope. x1, y1 is a point on the line. And then formula for all the applications. You still remember those? Yeah, we have area. So for 2-dimensional geometry, we have area and perimeter. Okay? And for 3-dimensional, we have volume. And also we have the temperature formula. The distance is c times sine. Compound inches. Compound continuously. Right, everybody? Quadratic formula. Yes, quadratic formula. This is what you get. And you don't need to learn completing the square because I didn't teach you. Actually, I teach you the vertex form, right? Remember the vertex form? A x minus h squared plus k, the vertex form. And I prove you that the h is negative b over 2a, and then the k is f of h. Do you remember that? So with this formula, then you don't need to do completing the square. Okay? Okay, it's 10:50 now. So this is on the course website. Print it out and take a look. Yes, I hope I have given you all the resources you need to successfully. Good luck with all your finals. Have a nice day.
Monday.
Yes, Monday.
I have all the